Welcome to FM Tuition Academy. Okay. Those ones who haven't hit the subscribe button, down there's a red button written subscribe. Okay. So click the subscribe button. If you haven't subscribed, click the subscribe button. Okay. So you click the subscribe button. Now, today we are looking at refraction, reflection, refractive index, refractive index, this is F, refractive index. So these are the main things that we're going to look at today. Okay. Now, in grade 7, if you remember, actually in grade 8, we learned that if this is a flat surface and then this is a medium here on top, there is medium. We did this in grade 9, so we're doing a recap, but it also comes in grade 12. So if this is a medium, okay, this is medium 1 on top, medium, there's a medium on top, and then there's a medium down. Okay. So I draw a cross like this. So if a light source is coming, maybe this medium on top is air. Okay. Let's say this one is air, and then the medium down is a solid or glass. Let's just say the medium down is glass. Okay. Which one is more dense? Which one is stronger? Which one is denser? The air or the glass? The glass is denser. Okay. So when a ray of light is coming from this direction, as a ray of light is coming from this direction, when it hits this surface, it will be reflected upwards. Okay. Okay. Now, this ray of light entering is what is called incidence ray. The ray of light entering is called incidence ray. This one is called incident ray. Incident ray. Okay. The ray of light entering, I don't know if you can see the spelling properly. The ray of light entering is called incidence ray. Incidence ray. Okay. Incident ray. Okay. That ray of light entering. And then the one that comes out this side is called reflected ray. With a E, reflected ray. Okay. So let's say this is a block. This is glass here. I said this is a glass surface. Okay. And then the one that enters inside here, the one that enters in here and then bends inside here, it bends. When it enters here, it bends. This one is called the refracted ray. this one is called the refracted ray. So this ray is called refracted ray. So this one is coming there. Now as it reaches here, it also comes out. So meaning here where it's coming out here, I'll draw another. This line, the one that is straight, this one, the red one, this line is called the normal. This line is called the normal. Normal. Okay? This line is called the normal. Okay? So this line, because of space, draw it on top there. This line is called normal. Normal. Okay? Normal. I hope you can see the spelling. The normal line. This straight line is called the normal line. Normal line. Normal. So again, even here, again here, there's another normal here. Okay? This is also called the normal. That line is also called the normal. So these two ones, the red lines. This line here is called the normal. Even this other line is called the normal. Now, the ray that comes out from the normal, the other normal, the one that is outside, this other normal, this side. The ray that comes out from this normal, the one that is coming out this side, is called emergent ray. They can ask you to label this emergent ray. It's called emergent ray. What about the angles? Okay, here we're dealing with the rays. Okay, these are the rays that you have in physics on light. These are different type of rays. There's incident ray, reflected ray, there's the refracted ray, and then emergent ray. Okay, because they can ask you about rays and two normals, the normal on top and the normal down where the light is coming out. Now let's look at the angles. What about the angles? So I said if this is a block, okay, if this is a block, and then there is a normal here, okay, and another normal here, okay. A ray of light is coming from this side, comes here, it is reflected this side. I talked about this is incidence ray, refracted ray, okay. Incidence ray, reflected ray. This is reflected ray, and then this layer of light comes. It comes here, as I said. This is refracted ray, and then when it reaches here, this other ray, this side is called this ray. This side is called emergent ray. Okay, emergent ray. Now we're going to focus on. You are now focus. This is a normal here. I think I've explained. This one is a normal. Even this other side is a normal. Okay. We're looking at the angles now. So the basic angles that you have, those angles, the ones that are near the normal. I repeat, the angles should be near the normal, not away from the normal. They should be attached to the normal, not this angle. Okay. You pick the angle that is attached to the normal. So the one that's attached to the normal here is this one. You see, that's the one that's attached to the normal. Same also this side, the one attached to the normal is which one? This one. Is it clear? That's the angle attached to the normal. Okay? Even here, down here, what angle is attached to the normal? It is which one? The angle attached to the normal here is which one? This one. Okay? Okay, I'll use the ones that are widely used so that I don't spend so much time. I'll just show you what is very important in the exam. The ones that are mostly used. Okay. These ones I'm putting them in the same color because they are same. So this angle and this angle are same. Okay, they are all attached to the norm. Now this angle here, since this one is incidence ray, the angle here is called incidence angle. Incidence angle. It's called the incidence angle. So this angle here is called the incidence. I hope it can fit. Incidence angle. Is the spelling clear there? Let me use another color so that you can easily read it. It's called incidence angle. So use that color. It's called the incidence angle. Incidence angle. Okay, because that ray is called incidence ray, so even the angle is called incidence angle. And then this one inside here, you see the one inside here, this ray is called refracted ray. You remember the rays? This one inside is called refracted ray. So it means this angle here, this one, is called angle of refraction. And then this angle here is called the angle of emergence. This one, because this one is an emergent ray, so this one is called the angle of emergence. Angle of, there's no space, angle of emergence. Okay, those are the most two important angles. Okay, now based on that knowledge, I repeat, now we can proceed. So you need to know these angles, and all these angles are attached to the normal. All the angles are attached to the normal. Have you seen this one is attached to the normal? That angle there, even this one is also attached to the normal. This angle, same with this angle, is also attached to this normal. These angles should be attached to the normal, not away from the normal. Now let's look at the calculations now, because they'll ask you about calculations sometimes, or when they ask you to label the angles or the rays. So for example, we're looking at there's what you call refractive index. Refractive index. Okay, the formula for refractive index is N is equal to sine I over sine R. Okay, I is the angle of incidence. I is incidence. So I is the angle of incidence, the one that's entering. And then R is the angle of refraction, not refraction, reflection with A. Angle of refraction. Okay, angle of reflection. So let's look at an example. This is an example. Okay, so if for example that is a prism, guys, and then this is a ray of light. It's coming here, and then some of it is reflected this side. Incidence ray, reflected ray. The other one has come like this. This is, again, there's another normal here. Let me use the normals. I'll write them in a different. And this is a normal here. Again, another normal is here. Okay. And then they give you the angle here as 30. They give you another angle here as 40 or 26. That angle there is 26. There's no space, so I'll just put outside here. I'll say, for example, 24 degrees. Okay. And then the question is calculate. The question is calculate the refractive index. So the first thing you do is you write the formula. Refractive index is equal to sine of the incidence ray over sine of the reflected ray. I, this is I, in case you don't know I. So is equal to sine of the incidence ray. Which angle is incidence? The one that is near the normal. Which one is near the normal? This one. The one that is near the normal. The one that is attached to the normal. That's one you pick. So incidence angle is 30 degrees. The one that is next to the normal. Incidence angle, you put 30 degrees over sine R. What is R? R is a refracted ray. The one that's near the normal also. Have you seen this one? The one that is near the normal. That's one you pick. The one near the normal. You always pick the angles near the normal. So this one is 26. 24, I mean, sorry, 24. So 24. And then you punch on the calculator sine 30 over sine 24. I don't have the calculator, so when you punch, you write the answer that you're going to get here. How to punch on the calculator, you know. Okay, example 2. Example 2, again, they can give you a surface like this. Okay, and then this is the incidence, this is reflected, and then the, okay, it can come like that. Okay, so this is a normal here, as you can see. There's another normal here. Okay, and then the angle there is coming out this side. This one's been reflected. Okay, and then here they can give you, let's say, 20 degrees. I said this angle here is always equal to this angle. Even if I haven't told you, this angle is always, they're always equal, this angle and this angle. They may not tell you. And then meaning this one is also 20. Okay, then this one maybe they've given you a 70. Okay, let me not put this one first for now. Let's say they've just given you those two, and then they've also given you okay, it's fine. They've given you 70 there. Even this side they've given you 70. Okay, and then here they've given you 31 degrees. Okay, because of space, I'll put here. This one is 31 degrees Celsius, and then this one, this side. Okay, let me not use 31. Let me use an easy number like 30. This one is 30 degrees. Okay, and then this one is 60 degrees. Okay, this angle from here to here. And then the question is calculate the refractive index. Okay, calculate the refractive index. So n is equal to, refractive index is equal to sine r over sine I, not sine r, sine I over sine r, which is equal to sine I. So sine, what is the incidence angle? The one that's attached to the normal. Don't get confused with all these angles. The one attached to the normal, that's one you use. Which one is attached to the normal? The normal is which one? What is my normal here? The normal is the one in black. Okay, so you pick the angles that are near this normal. So which one is near the normal? The incidence angle. it is 20. This is the one you pick. Okay, so 20, that's the one you pick. You don't pick any other angle here, not 70, not what. So you pick the one that is attached to the normal from the incidence ray. The one that's attached to the normal is the one that is next to the normal is 20. So that is 20 divided by sine r is what? Also, you pick the one that's attached to the normal. You don't pick 60 here, no. 60 is away from the normal. The normal is here. Okay, so the one attached to the normal is this one. Okay, which is that. So it's this one here and this one here, which is this one here, the angle here. So these two angles, this angle and this angle, are the ones that you pick. So 30. Okay, and then you punch on the calculator sine 20 over sine 30. The answer you get, you write it down here. Okay, so that's how you calculate these. See example 3. So this continues, it's just like that. Sometimes a thing can come like that, like this. Here they can give you 70, for example. Okay, here they give you 30, for example. Actually, I don't. They can give you even 50, for example. They can give you 50 here. Okay, and then this is incidence, this is reflected. Again, they can say calculate the refractive index. They can say calculate the refractive index. Okay, so how do you calculate? So refractive index is equal to sine I over sine R, which is equal to, so which one? You always pick the angle that is near the normal. That's what you said. So which one is the normal? My normal is this one. So which angles are near the normal? Is it 70? No. The angle near the normal is this one. Okay? The one that's near the normal. Okay? And how do you calculate that angle? This whole angle here is 90. So to calculate that angle, it will be 90 minus this 70 here, minus the 70. We are going to find that the angle there is 20 degrees. Okay? So at 20 plus 70, it makes 90. Okay? Same here, the angle that you pick is this one. It's not the 50, no, it's this one. You pick the one that is near the normal. I repeat, pick the angles near the normal. Okay, meaning even this one here again is going to be 90 minus 50, which is equal to what? 40 degrees. So meaning here also is 40 degrees. Those are the two angles we use, the 20 and the 40. So sine 20 degrees over sine 40 degrees. Okay, is equal to, then you punch on the calculator, sine 20 divided by sine 20 divided by sine 40. That's the answer you write. That's how you deal with these angles, guys. This is exactly how you deal with these kind of questions. Okay? Okay. Sometimes they can give you, it can come in whichever way, guys. They can give you in whichever way. It doesn't matter. They can give you in whichever way, guys. They can give you in whichever way. So the line can come like that. This one is entering. This one is coming out, like that. Okay. That one can be coming like this. You see, they can give you here, for example. They can give you 80, for example, here 80 degrees. Okay. And then yes, they can give you 80 there. And then they can give you the angle from here to here. They tell you the angle from here to here. It's maybe 130, for example. Okay, that's the angle they've given you from there to there. And then they ask you to calculate the refractive index. How can you do it? Okay, calculate the refractive index. So you look for the incidence angle. Which one's the incidence angle? Is this one. As I said, the one that is next to the normal. The angle should be next to the normal. I told you, next to the normal. The angle should be next to the normal. Okay? The angle should be next to the normal. So this angle there. So what do you have? What do you have there? We're going to pick them. What do you pick? So there it's going to be 90 minus 80, which is 10. So here it's 10 degrees. Okay, so at this 10 plus this 80 make a 90. Okay, and then even here the angle we pick is this one. So these are the two angles we pick, this one and this one. Okay, but how do you find this one? How do you find that angle? Okay, because from here to here, don't forget, from here to here up to this side, this whole angle here, it is 130. So from there to there it's 130. So meaning we chop off this 90. Okay, this whole angle here is 90. This one, all of it is 90. So we have to chop off the 90 from the 130. So that when you chop off the 90 from the 130, what will remain is this one here. So this whole angle is 130. When you remove the 90, this part here is 90. This one, from here to here, it's 90. Okay? The 90 is from here to here. Okay? From here to here, it's 90. So when you chop off the 90 here, what will remain is this one, which is the angle that we are looking for. So it will be 130. You remove 90. Okay? So 130 minus 90 is what? 40. So meaning this angle here, it's 40 degrees. Okay? So refractive index is equal to sine I over sine R, which is equal to sine I, which is sine 10 degrees, okay, divided by sine 40, and then you punch on the calculator. I was just showing you to make you understand how to use the process. Okay, that's how you calculate this. That's all, guys. I think this is enough. The rest is for you to discover on your own and try them out. Okay, to discover on your own and try them out. So this is the exercise. This is the exercise. You can try it out. I'll just write some few questions. So that is the exercise. Okay. So it's calculate the refractive index. So that is 31. That is 40 degrees. That's question 1, I believe. This is question 1. Let's go to question 2. Question 2. There were things like that. This is 30 degrees. This is the 40 degrees. See, calculate the refractive index. Okay, calculate the refractive index. Okay, the other one is question 3. They can give you this one as the 60 degrees, and then from there to there can give you 140 degrees, and then they say calculate refractive index. Okay, question form. Actually, there's something I didn't explain. So those are the 3 questions. You have to do that exercise. Before I cut, there's something. Sometimes they can say, I'm continuing the lecture. Sometimes they can say, calculate the incidence angle, when the refractive index is 40. When they say the refractive index is 1.2, and angle of reflection is, it's another example, angle of reflection is 40 degrees. They can write a question like this. So you need to know how to, because it's not always they'll bring them in the diagram. Sometimes they can bring it in a sentence form, where they say calculate the incidence angle when the refractive index is 1.2 and the angle of reflection. Meaning such questions you use the formula. So you first write this formula. Refractive index is angle of reflection, angle of incidence over also it's on sine r. So they are saying the refractive index is what? According to the question, from looking, the refractive index is 1.2. So on the refractive index you put 1.2. So here on the refractive index you put 1.2. Okay, that's what you put, is equal to, and then they want us to find, they have also given you angle of reflection. The angle of reflection here, it's actually 40. So on reflection angle we put 40. So we're looking for incidence, so we're looking for sine I. Okay, the sine r, the incidence, the angle of reflection is 40. So here on r I put 40, and then you make I the subject. This is simple mathematics, so don't get confused. 1.2 is equal to sine I over sine 40. Okay, your mathematics needs to be good. You need to be good at mathematics. So any number on its own is over 1, then you cross multiply. Okay, you make sine r the subject. So this 1 times this sine r, you say 1 open bracket times sine r, that's how you do in mathematics, is equal to this 1.2 you multiply it by 1.2, you multiply it by sine 40. Okay, so 1 times sine r, it will be sine r, is equal to, okay, 1.2 sine 40, 1.2 sine 40. Okay, so 1.2 sine 40. So sine r, sine I, sine r, sine, not sine r, this is sine I. Here it's I. This is I. Okay, we're multiplying that angle of incidence. This one, that is I. So even there it's I. Okay, I think you know what I'm doing. So sine R is equal to 1.2 sine 40. Okay, and then what you do, you're trying to find I. So you punch this on a calculator. This one, I do not know, I don't have a calculator. So when you punch on the calculator, I don't know the answer you get. Maybe the answer you'll be punching, you'll be using a calculator. So maybe the answer you get is 0.0, maybe, or 1 point, I don't know, whatever answer you get, or maybe 1.3467, whatever. You write that answer, all of it. And then this side it is sine I. So to find I, this sign goes to this number. So it will be sine inverse. You have done trigonometry in mathematics from grade 10. So this is 0.03467. So I is equal to, then you punch, that is I. That is the angle of, so when you punch this, the answer you get, that is the angle of incidence. Okay? So you punch 1.2 sine 40, you get the answer there. And then I is equal to the sine inverse of that answer, because this sign goes this other side, and then it becomes sine inverse. So that's how you do this. Okay, based on that, I'll bring one question from that example. From those other questions I've given you, the last question is, this is the last question, okay? The last question, okay? Don't get confused. Okay, calculate the angle of reflection. Now this is reflection. There it was angle of incidence I was asking. Calculate the angle of reflection when the refractive index is 0.14 and angle of incidence and angle of incidence and angle of incidence is 30 degrees. Okay, that's all. So this is the end. Calculate those. The other things, this knowledge, you need it when you're dealing with practicals. So when I bring some few practical videos right now, you're going to not realize that you need to know the refractive index. Okay, end here.